Assalamu alaikum and good afternoon everyone. In previous video we have discussed minimization total cost and maximization total profit of assignment problem of balance example. In this video we'll be discussing unbalanced example of assignment problem using Hungarian method. So let's begin with the question. Five students appear in the four subjects. Marks are given below. Find the number of students failing in subjects, where the subjects are given as A, B, C, D, and number of students are 1, 2, 3, 4, and 5. So the question was asked in November 2021 of University of Mumbai. So let's begin with the solution. To check whether the given cost matrix is balanced or unbalanced. Balanced means number of rows and columns are equal. Unbalanced means number of rows and columns are not equal. So here we can see the given cost matrix is unbalanced since the number of rows are 5 and number of columns are 4, and which is not equal. Here we can see the number of students are 1, 2, 3, 4, 5, and number of subjects are A, B, C, D, that is 4. So the given cost matrix is unbalanced. As the number of column is 1 less than the number of rows, we introduce one dummy column, convert the given assignment problem into balance problem. The number of students in each cell of this column is taken as 0. So here we are going to introduce one dummy column to make the problem balance, that is number of rows are 5 and number of column will be 5, but each entries of the cost matrix will be 0 of that particular column E. So first step, now we can see the given matrix is your cost matrix is balanced. So first step is your row minimization. Locate smallest element from each row of cost matrix and subtract every element from smallest element of that row. Continue this process for all rows. As we can see, the minimum value in first row is 0, second minimum value 0, third minimum value 0, fourth minimum value 0, fifth minimum value 0. As we know that any number is subtracted from 0, the number will going to get itself. So there will be no change in row minimization of the resulting matrix. Is your column minimization in the resulting cost matrix. Locate smallest element from each column of cost matrix and subtract every element from that smallest element from that smallest element. So here we are going to check for the minimum column value. We can see the minimum column value. The minimum entry is 10, 20, 10, 20, and 0. So minimum entries are 10, 20, 10, 20, 0. From each entries we have to subtract 10. So the resulting cost matrix we get is 40, 30, 50, 20, 0, and so on, the resulting cost matrix. Now step 4 is search for the optimum solution. Examine the rows successively until a row with the exactly one zero is found. Draw a rectangle around this zero in the given format and cross out all other zeros in the corresponding column. Proceed in this manner until all the rows have been examined. If there is more than one zero in any row, do not touch that row, pass on to the next row. Repeat step A above for the columns of the resulting cost matrix. So here we can see the resulting cost matrix. We're going to do the allocation. In first row, the number of zeros are more than 1. So we're going to skip that row and cancel out all other entries from that column. In third row, again more than one zero, skip that row. In fourth row, there is no zero. In fifth row, there are more than one zero. So skip that fifth row. Column there is only one zero, so we're going to cancel out all other zeros from that row. So here we can see in second column we are having only one zero, so cancel out all entries from the row. And from the third column there is no zero. From fourth column we are having only one zero, so we're going to cancel out all the entries from the row. Here we can see the number of lines and order of matrix is not equal, so means solution is not optimal. So number of lines are 4, that is 1, 2, 3 and 4. So number of lines are 4 and order of matrix is 5, which is not equal. So we are going to revise the cost matrix as follows. Find the smallest element not covered by any of the lines. Subtract this from all uncovered elements and add it to the element to the intersection of the two lines. Other element covered by the lines remain unchanged. So here we can see from uncovered entries of the resulting cost matrix, the minimum value is 10. Minimum value is 10. So minimum element among uncovered entries is 10. Subtract 10 from uncovered entries and add 10 at the intersection of line. So we're going to get the resulting cost matrix as you can see on your screen. Same step we're going to repeat for the optimum solution. So in first row, the number of 0 is 1. So we're going to allocate that 0 and we're going to cancel out all other entries from that column. In second row, there is more than 1 0, skip that row. In third row, there is only 1 0. So allocate that 0 and cancel out all other entries. From fourth row, again more than 1 0, skip. Again from fifth row, more than 1 0, skip that row. From first column, there is only 1 0. Allocate that 0 and cancel out all other entries from that row. In column C, in third column, we can see there is only 1 0. Allocate that row, allocate that entry and cancel out all other entries from that row, and only 1 0 left that we have to allocate and cancel out all other entries from that row. Here we can see the number of lines is equal to order of matrix 5, hence the solution is optimal. So number of students are 1, 2, 3, 4 and 5, and number of subjects we have got after allocation. As we can see, 1 is assigned to D, 2 is assigned to E, 3 is assigned to B, 4th is assigned to C and 5th is assigned to A. In this way we are going to make a sequence, and the here we can see the total number of failing students are 20, 0, 20, 20, 10. Total count is 70.